Hello, this is my third lecture on integral calculus for second SEM honors GE and DSC students. I'm Ms. Ranjana Dutta from the Department of Mathematics, the Graduate School College for Women. Today we will study the reduction formula. Now, see on your screen, integration of x into sine to the power nx dx and integration of x into cos to the power nx dx. Let us suppose this is equal to in. So in is equal to integration of x sine n to the power x sine nx dx, which can be written as x sine n minus 1 x into sine x dx. Now applying the integration by parts, taking sine x as a second function and so on. So x sine n minus x is taken as one function at a time, and integration of sine x is minus cos x. And then again the integration of sine x is minus cos x, and the differentiation of x into sine n minus 1x, differentiation of again x into sine n minus 1x. So x into n minus 1 sine n minus 2x into cos x dx, integration of sin x is cos x dx, and then sine n minus 1x into dx. So after that we get minus x sine n minus 1x into cos x and n minus 1 x into sine n minus 2x cos square x dx plus sine integration of sine n minus 1x cos x dx. Above integration do properly, otherwise you cannot reach this. Okay, then x into sine n minus 1x into cos x plus n minus 1 x into cos square x can be written as 1 minus sine square x. And so after putting these values we get x minus x sine n minus 1x cos x plus n minus 1 x into sine n minus 2x dx minus n minus 1 x into sine n to the power nx dx plus sine to the power nx by n. Here see minus n minus 1 x into sine to the power nx dx can be written as minus n minus 1 in. So left hand side in is equal to minus x sine n minus 1 x into cos x plus n minus 1, and x sine n minus 2x can be written as in minus 2, and the next function minus n minus 1 in and plus sine n to the power n into x by n. So taking this n minus 1 in on the left hand side, we get in is equal to 1 plus n minus 1 is equal to minus x sine n minus 1x into cos x plus sine nx by n plus n minus 1 in minus 2. So in is equal to written whatever you can see on your screen. Similarly, for x into cos to the power n, cos nx dx can be written as you can see on your screen. Now, take one example. Un is equal to 0 integration of theta sine n theta d theta, and n is greater than 1, and the limit is from 0 to pi by 2. Prove that un is given on your screen and deduce that u5 is equal to 149. So un is equal to 0 to pi by 2 into theta sine n theta d theta. Again, using the previous one as the previous one, we can write it as 0 to pi by 2 theta sine n minus 1 theta into sine theta d theta, and after integrating and putting the limit, you can see whatever is on your screen. So sine n theta by n, limit 0 to pi by 2 plus n minus 1 into integral over theta sine n minus 2 theta into 1 minus sine squared theta d theta, which can be written as 1 by n plus n minus 1 u n minus 2 minus n minus 1 un. You see here, comparing the previous example where the in is equal to x sine n minus 1 x into cos x, you can do this problem using the formula, previous formula, or you can do this uh, as uh, shown on your screen. So we can write it as un is equal to 1 by n plus n minus 1 un minus 2 minus n minus 1 un, or un is equal to 1 by n square plus n minus 1 by n into un minus 2. Now putting n is equal to 5 and 3 successively, we get u5 is equal to 1 by 25 plus 4 by 5 into u3. Also u3, putting n equal to 3, we get u3 is equal to 1 by 9 plus 2 by 3 into u1. But u1 can be written as theta into sine theta d theta within the limit 0 to pi by 2, which after calculation and putting the limits, we get this is equal to 1. So u5 is equal to, after calculation, it becomes 149 by 225. This is an example of reduction formula. So you try the homework at home given on your screen, which is very, very important. So student, today this much only. Thank you.